Hi. White matter is made up of myelinated nerve tracts and acts as a relay, coordinating communications between brain regions. Myelin is a protective sheath composed of fatty lipids, which greatly enhance the efficiency of these communications. And in fact, this myelin is what makes white matter in the human brain appear white. The development of myelin is a complex process that begins in fetal life and continues into adulthood and is linked to the maturation of cognitive abilities. Puberty is an important stage for studying myelination because it establishes the foundation for essential brain connectivity that enables cognitive and behavioral advancements. Dysfunctions in myelin development during puberty may contribute to adverse mental health outcomes. I am fortunate to work on a large-scale NIMH study of pubertal neurodevelopment, which allows us to longitudinally study healthy children between the ages of 8 and 18 every 9 months. This graph here is a snapshot of about 20% of our participants, where each line represents a child and each dot represents a visit. Importantly, the color of the dots represents pubertal status, which was carefully assessed by doctors using a standardized 5-point scale, where stage 1, which are red dots, indicates prepubertal development, and stage 5, which are purple dots, indicates full maturation. My aim in this project was to use MRI to quantitatively measure myelin to better understand the developmental patterns in myelination that are associated with different rates of pubertal tempo. Pubertal tempo refers to the rate at which pubertal stage evolves and is an important parameter to assess as it has been linked to mental health outcomes and myelin changes. At some point in their development, some children will go through the pubertal stages relatively quickly, as seen in this example, where this child went from pre-puberty to adult maturation by age 13, and these visits would be categorized as fast tempo. On the other hand, some children may stay in one stage for many years, such as in this example, where this child only reached mid-puberty by the same age, and these visits would be categorized as slow tempo. In the results, I found that there were developmental patterns in myelin associated with pubertal tempo that differed between boys and girls. This yellow region here represents the white matter with high myelin content in the brain, and specifically, in boys, fast tempo was associated with greater myelin than slow tempo across the entire brain. In contrast, in girls we see a different pattern. Girls with fast tempo have a faster rate of myelin development compared with girls with slow tempo, where they start out with less myelin but end up with greater myelin at later ages. These preliminary data may contribute to differences in the rate of maturation of cognition and behavior observed in adolescence. And since puberty is a time associated with a substantial surge in hormone exposure, future directions using this same group of children will involve understanding the effects of sex hormones, such as estradiol and testosterone, and their joint impact on myelin development. Thank you.